Hey everyone, welcome back. In this lesson we're going to be talking about the metric system. So this is another introductory lesson for our math course before we jump into geometry. So this is a lesson that I could have put into the math course, which I've done. I could have also put it as an introductory lesson in science because we'll be when we discuss, the sizes of different things, the masses of different things, um, and lots of other things. We can talk about time, we can talk about energy, we can talk about charge, we can talk about lots and lots of different quantities, and a lot of them use units of some kind. And we're going to talk about one particular system of units in this lesson, which is the metric system. So first, what is a system of measurement in general? So a system of measurements is it's a collection of, well, you can read right there on the line. It says it's a collection of units and the rules that relate them to each other. So what that means is you can have different units to represent different sizes of something. So for example, you could be talking about distances, and you could have units to talk about things that are really small, like centimeters, and then you could have units to talk about things that are really big, like really far away, like kilometers. And what the system of measurement does is it has these different units. It could be for anything. It could be for time. It could be for distance. It could be for weight. It could be for volume. It could be for whatever. Um, the idea is that you have different terms that you can use to describe things that are sort of on the smaller end of that scale, and different terms to describe things that are on the larger end of that scale. And you have rules that relate those different words to each other. So a common one being a common example could be the relationship between feet and inches. 1 foot consists of 12 inches, right? So that's an example of two different units, one unit being the foot and the other unit being the inch, and a rule that connects the two of them. The relationship between how many inches go in a foot tells you how to go from inches to feet and feet to inches. So if you have a measurement that's, three and a quarter feet, and you want to convert that into inches, there's a way to do that because we know how to relate feet and inches to each other. Similarly, uh, if you had a measurement that's completely in inches and you had 78 and a half inches, there's a way to convert that back into feet. So that's an example of units and the rules that relate them to each other. Now, there are two famous systems of measurement that we use, especially because we use them in different ways for measuring distances. And one of them is exceedingly popular around the world, and that's the one in red here, the metric system. But there are a few countries, the United States being one of them, that continues to use the imperial system. So we'll take a brief look at the imperial system and some of the words associated with measurements in the imperial system, and then we'll focus the rest of our time in this lesson talking about the metric system. So here is the imperial system. Here's just a few words that describe different quantities. In the imperial system, we've got a few words that describe distances. There are more words that describe distances, just as you can see here in this screenshot from Wikipedia, that there are plenty of words here. These are all measuring distances. They're all related to feet in some way, basically. And they're all related to each other. And you can see that, we've got, of the 4 words that are listed up there, where's my pen? There we go. So we've got inches here, we've got feet here, we've got yards here, and we've got miles here. Those are the 4 words that we have listed right here, right? So these are different examples of ways that you can measure lengths and distances in the imperial system. So if you go to the United States for vacation, you won't see meters, you won't see centimeters, you won't see kilometers, you'll see a lot of this. You'll see a lot of inches, and feet and yards and miles. The rest of them aren't particularly common, I think. Some might be more common than others. For example, I know that I've come across the term furlong before, and I've come across the term, well, actually, I think that's the most um, sort of famous of the rest of them. But in terms of a unit of measurement, I haven't come across league or chain or hand or barleycorn. Um, so there are definitely some strange, obscure units that maybe you will never come across in your life, but I'm just giving you a taste for the kinds of words that you might see uh, in the imperial system. So these four refer to distances, lengths and distances, um, but these are different. Uh, so if you've ever, gone to fill gas in a gas station that either is like in the United States where they use the imperial system, or perhaps somewhere else that uses gallons instead of liters, then you might already be familiar with this word. So pints and gallons um, refer to volumes, and this is different from the metric system where we tend to use liters and then variations of the liter. So like a tenth of a liter or a thousandth of a liter or things like that. Um, so the imperial system has these different words for volumes and these different words for weights as well. You might hear often that a newborn baby is born and they weighed 7 pounds 6 ounces or something like that. They're giving a measurement of weight using words like pounds and ounces. But in the metric system, we'll use a bunch of different words like kilograms. So that's sort of the common way to describe weights in the metric system, and you'll hear people talking about it. If you talk to Americans about how tall they are, they'll give you the answer in feet and inches. They'll say like, "Oh, I'm 5'6", 5'7". They mean 5 feet 6 inches or 5 feet 7 inches tall. And if you ask them how much they weigh, they'll give you a response in pounds. They'll say like 150 pounds or something, or 190 pounds or whatever, right? But if you go to Europe, where they predominantly use the metric system, and in fact, I, I don't, I've never met someone from Europe who doesn't use the metric system, um, uh, in most ways at least. Uh, but if you ask somebody from Europe how tall they are, they'll probably give you the answer in centimeters. And if you ask them how much they weigh, they'll give you the answer in kilograms. Now, for me, being in Canada, it's a little bit unique in that as a country, we use the metric system, but I know my height better in the imperial system and my weight better in the imperial system. If somebody asks me how tall I am or how much I weigh, I'll give the answer in feet and inches for my height and pounds for my weight. Um, Whereas for almost anything else, if you ask me how much something weighs, I should probably be using kilograms, because as a country, Canada tends to use the metric system, and kilograms is an example of the kilogram is an example of the metric unit for measuring weights. Anyway, that's enough for the imperial system. Let's get into the good stuff. So, here are some words that describe various quantities in the metric system, and we'll take a look at the relationships between some of them in the rest of this lesson. This shouldn't be a ridiculously long lesson, but you know how I go on, especially with nobody to stop me. But anyway, so I've done sort of the same thing. I've grouped together words that are related to certain quantities in the metric system. So these first four are all related to lengths and distances. And then these two over here are for volumes. And these three down here are for weights. And I've included this big 10 over here, this big fancy 10, because that's sort of the central idea of the metric system, is that within a given uh, sort of thing that you're trying to describe, so if you're trying to describe a length, you have a single base unit, like in the case of measuring lengths and distances, it's the meter, and then every other unit that you could use to describe lengths and distances is some uh, multiple of a meter in groups of 10. So maybe it's 10 times bigger, or 100 times bigger, or 1,000 times bigger than a meter. Or you can go in the other direction. You can have something that's a factor of 10 smaller than a meter. So you could have a tenth of a meter as a unit of measurement, and you could have a hundredth of a meter as a unit of measurement, and a thousandth, and so on. And you could extend that as far as you want. So that's sort of the idea. You'll have this base unit like the meter, and then every other unit that you could use to describe lengths and distances is some factor of 10 bigger or smaller. So it could be 10 times bigger, maybe it's 1,000 times bigger, or a million times smaller, or something like that. But it's always 10, 10, 10, 10, 10. And I didn't point this out when we were looking at the imperial system, and I can't go back a slide when I'm recording like this, unfortunately. But if you pause, if you go back, you'll see the strange relationships between the different units in the imperial system. I can never really keep it straight in my mind, and as a result I don't know all the conversions. But for example, you've got 12 inches in a foot, and then you've got 3 feet in a yard, and it's hard to follow any sort of logic between why those, like, why is it 3? Why isn't it also 12? Why isn't it a nicer number that we can, multiply and divide by easily, like 10 or 2 or something like that? So the imperial system I find to be really weird because the conversions between different things don't really make sense to me. Now, I understand that for people who've grown up using the imperial system, for some reason the metric system doesn't make sense, and that's fine. If they're not used to the metric system, then whatever. But for me personally, the imperial system strikes me as odd because I don't understand the reasoning for those different numbers being the conversion factors between, if we want to go from um, you know barley corns to yards, I have no idea how to do that just off the top of my head. Or, inches to furlongs, I just don't know the right numbers that I would need to know in order to do that conversion properly. Whereas in the metric system, once you learn what these things at the beginning of certain units, once you learn what they mean, so like the milli and the centi and the kilo, um, and things like that. Once you learn those prefixes, um, then you're basically set, and you can apply it to measuring different things as well. So what I mean by that is, in the imperial system, you have to learn all these different conversion factors of, like, inches to feet and feet to yards and yards to miles and all of that. But then that only applies to lengths and distances. And then when you go over to ounces and pounds, now there's a different conversion factor. And if you go over to pints and gallons, there's a different conversion factor. And you have to learn all of those independently. In the metric system, once you learn these prefixes, milli and centi and kilo, and the others, which we'll see in a minute, then you can apply that to anything. You can see we've got centi again here, even though we're talking about volumes, and we've got kilo over here, even though we're talking about weights and masses, right? Um, so that's maybe that reasoning of, everything is a factor of 10, and you can take these same prefixes and apply them from one thing to the next to the next. Maybe that's why the metric system is so popular in this day and age. But anyway, it is, since it is so widely used, I think it's important that we take a lesson to explore it, which is what we're doing here today. So here are the common prefixes in the metric system. Now, of course, there are a lot more, and I'm going to show you those as well. But so basically, we start with, if you read this first line, it says, we use prefixes to create new units that are all related to one central unit, which has no prefix. So what I mean by that is, you'll have this one sort of starting point, like, for example, a meter. In the metric system, we can measure lengths and distances using sort of this standard centralized unit called the meter. And then if we want to make a unit of measurement that's smaller, you know, if you want to measure how long your 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 pencil is, you probably shouldn't be taking a big long meter stick just to measure out how long your pencil is. It would probably be better to use a smaller instrument like a ruler and give your answer in centimeters, because it's it's more reasonable. Or maybe decimeters, but that's not the most common of units. But anyway, the idea is that if you need to measure something that the meter is just sort of not the right size to measure it, then you need to be able to make smaller and bigger units, right? If I want to talk about the distance between where I live and where your school is, that's not an efficient distance to write down in meters, right? Um, for distances that are just too big, it's better to use larger units, so just so that we can keep the number of the number of them smaller. So what I mean by that is, for example, for me to go from my house to my high school, um, where I went to high school, is 2,500 meters, or 2.5 kilometers. So things like that. So if you use a bigger unit like a kilometer, which is 1,000 times bigger than a meter, then the number in front of it gets smaller. So I could say it's 2,500 meters to my high school, or I could say it's 2.5 kilometers to my high school, or kilometers if you prefer that pronunciation. Um, but so that's the idea. So we start with the meter, and then for some things it's more useful to have a smaller unit of measurement, so we need to invent smaller units. And for other things it's useful to have bigger units of measurement, so we could invent bigger units as well. So the idea is to create smaller and larger units. Basically, we just tack on one of these collections of letters, one of these prefixes, before the name of the base unit. So with our base unit being the meter for lengths and distances, bear with me, I'm drawing with a mouse and not a touchpad or one of those special writing pads, so sorry about that. But basically, so if for lengths and distances we're using the meter for our measurements, then if we want to invent a unit that is 10 times smaller than a meter, remember that everything in the metric system works in groups of 10. So if we want something that's 10 times smaller than a meter, then we add this deci in front of it. And if so a tenth of a meter is a decimeter. And then if we want to extend that and we want to make something that's a tenth the size of that, so a tenth of a decimeter, we add in a centi in front. So instead of a meter or a decimeter, now we have a centimeter. And you guys are familiar with centimeters, right? That's this 0 to 1 on a ruler when you're looking at the metric side of the ruler. And so because we've got that a centimeter is a tenth of a decimeter, but a decimeter is a tenth of a meter, so we have that a centimeter is a tenth of a meter. And what that means is that it's actually 1/100th of whatever the base unit is. So in the case of lengths and distances, we're talking about meters. So 1/100th of a meter is a centimeter. And then we can extend that idea further. We can go smaller than a centimeter. We can do 1/10 of a centimeter is a millimeter, right? A millimeter. And because a millimeter is a tenth of a tenth of a tenth of a meter, then that's actually 1/1000th of the base unit, so 1/1000th of a meter. And so that's basically the way it works, and it works the same way in the other direction, except instead of tenths, now we're talking about tens of something. So if I wanted a meter, if I wanted a unit of measurement that's 10 times bigger than a meter, so 10 meters in size, then that would be a decameter. Decameter. So going in this direction is 10 times bigger than the base unit. And then from here, if I want something that's 10 times bigger than a decameter, then I have a hectometer. And so that's 10 times bigger than a decameter. So a hectometer is 10 times bigger than 10 times the size of a meter. So it's actually 100 times the size of the base unit. So the base unit being a meter, 100 meters is 1 hectometer. And then you can extend that once more, that 10 times bigger than that. So we've got a meter, and then we did times 10, times 10, times 10. We get to 1,000 of the base unit. And in the case of lengths and distances, that is the kilometer. So it's the metric system's equivalent to a mile, but it is not the same. It's not measuring out the same distance. It's just our equivalent of what we use in the metric system to talk about really large distances. And that's basically the way it works. On the next couple of slides, I'll show you the extensions of what I've written here that go even bigger and even smaller. So basically, I'm going to extend this list out in both directions. We'll have smaller ones here and bigger ones here beyond the kilometer and beyond the millimeter. And I guess I should have thought about this before, but the pictures I'm going to show you, they're screenshots from Wikipedia where the larger units are up at the top. So be mindful that this list is sort of upside down in comparison to what you're going to see in a second. That we'll have the kilometers up here and we'll have the millimeters down here. So just keep that in mind in the next slide. So here we go. This is actually all one really large list from top to bottom. I had to get a little creative and sort of, snip it into two so that I could display the whole thing large enough that it's easy to read. But so basically what we've got is, if we start with looking at things on the bigger side, so larger than the base unit. So the base unit would be this one right here. It's one of itself. So like if we're talking about lengths and distances again, we could say we're talking about meters. I'm just going to write meter in here since this is a nice little empty space. Meter. There we go. Once again, apologies for the shoddy penmanship. It's a little difficult to write on the computer. But yeah, so suppose we've got just 1 meter as our base unit, and then we want to make it larger. We need a larger unit for some reason. So going up this table, 10 times the size of 1 meter, right? So 10 times the size of 1 meter is a decameter. And the symbol that we use as a short form is dA. So if you wanted to write down 1 decameter, it would look like 1 dA as an example, right? And every step that we go up here is going to be larger than the last in some way, but it sort of changes around in a second, so you'll see what I mean. So starting out here, a decameter is 10 times bigger than a meter. Sure, no problem. A hectometer is 10 times bigger than a decameter. Sure, no problem. We've seen that already. A kilometer is 10 times bigger than a hectometer. No problem. We've seen that already as well. So starting from the meter, going up, this is times 10, times 10, times 10. Everything else on this list beyond this point, I'm not sure if you guys can see that there's a slight color difference, that these two rows are white and then everything else is gray. And I imagine it's for this reason. And it's the same thing on this end, that these two rows are white and everything else is gray. But anyway, so starting from the meter, we go times 10, times 10, times 10. And then everything above this is times 1,000. Times 1,000, times 1,000, times 1,000, times 1,000, times 1,000, times 1,000, times 1,000 for all of these remaining units. So they're all 1,000 times bigger than one another, but it's still just, it's not very different from just groups of 10. It's just 3 groups of 10 instead of just 1, right? So instead of leaping up in tens, we start leaping up by the thousands. And so what that corresponds to is 3 extra zeros here every time, right? So when we went from 1 meter to 10 meters, we added an extra 0. And then we multiplied that by 10, so we added an extra 0. And then we multiplied that by 10, so we added an extra 0. And then after that, now we multiply by 1,000. So every time we go up, we're adding in 3 extra zeros. And you can see that if you need to pause it and study this, then you'll see that every number going up here has 3 more zeros than the previous number, up to going like the smaller units where we talked about it's just going in tens. But anyway, so these are the different prefixes that you can use in the metric system. So for example, if you wanted to talk about something that's 1,000,000 meters long, you could say it's a mega meter. 1 megameter is 1,000,000 meters. So what this is telling you is if you have this prefix in front of your base unit, then this is how many of the base unit fit into one of those. So if we look at a simpler example, one that's easier to understand, for 1 kilometer, we have 1,000 meters. So that's the way that you can read through this. Gigameter has 1 billion meters. So that's the way that you can sort of learn how these work. Nobody really tends to use anything above probably around giga. I mean, when we're talking about lengths and distances with meters and stuff, nobody goes above kilometer. Everybody stops there. But in terms of prefixes that you might expect to see somewhere, they don't tend to get a lot bigger than giga or maybe tera. I don't think I've ever seen at least these top three, in any of my textbooks or any of my courses or anything like that. There are numbers that get that big, but we just don't use these words to describe them. They're there though, so they are part of the metric system, and you could absolutely use them. If you needed to write down a 1 followed by 24 zeros as a unit of distance, if you're talking about that many meters, that is 1 yotta meter. So things like that. On the smaller end, on the opposite end, so here now we've got our base unit written at the top because everything else is smaller than that. So I'm going to write in the base unit one more time. If we're talking about lengths and distances, that will be the meter. Perfect. And getting smaller, we start with a meter and then we go down to 1/10 of a meter. So 10 times smaller than a meter. And this is a decimeter. Cool, we've already seen that. Going 10 times smaller again, we go from deci to centimeter. So this is 1/100th of a meter. And then after that, we go down to a millimeter. So this is another 10 times smaller than a centimeter. So we've got a tenth of a tenth of a tenth. So this is a thousandth of a meter. In the case of distances, of course, this could change if you were measuring something else. But so basically we've got deci, centi, milli, which we've already seen before. And now, similar to what we saw on the big side of things, on the small side of things, now we get smaller by factors of 1,000. So all of these things are 1,000 times smaller than the one above them. So for example, this one is 1,000 times smaller than that, 1,000 times smaller, 1,000 times smaller, 1,000 times smaller, 1,000 times smaller than the one above it, up to here. And then this one is only 10 times smaller than a centimeter, which is 10 times smaller than a decimeter, which is 10 times smaller than a meter. But so going all the way down here, we have other words to describe very, very small units. So for example, if you're talking about objects in daily life, maybe the meter is a useful unit of measurement. If you're talking about the height of a person, meters are fine. If you're talking about the height of a door, meters are fine. If you're talking about the length of a table, meters are probably fine. If you get down to something smaller, if you're talking about the size of a book, from top to bottom, then centimeters or maybe decimeters, but nobody really uses those. Centimeters or decimeters would be better. If you're talking about the size of a wallet, centimeters probably. If you're talking about the length of a pencil, centimeters probably, right? But then you can get smaller. If you wanted to talk about the length of an eyelash, maybe if you have long eyelashes, you could use a centimeter, but you should probably use millimeters because you could sort of fine tune how precisely you can measure it and still not have to use decimal numbers. So you could say it's like, oh, my eyelash is 8 millimeters long, something like that. So you could use it for, you could use a smaller unit like the millimeter for things like that that are still in the realm of the world that we can see, but not but it's too small for us to use centimeters to describe it properly. And then beyond that, then we get down to the size of um, things that you might see when you look into a microscope. And you'll get things that are micrometers in length, cells in the body, bacteria, things like that. That'll be on the scale of a millionth of the size of a meter long, would be something like a micrometer. And then going even smaller, we get down to nanometers. And this is when we start delving into the range of uh, the, the incredibly tiny things that we can still sort of conceptualize things that are nanometers in length. Not very well in our brains, but there are things that we can observe in nature that are at this scale. But when you get way down to things of sort of in this range down here, it's just ridiculously small. Now you're talking on the scales of atoms and smaller when you get down to this range. Actually, you're probably getting down to the scale of protons and smaller. That scale of atoms is somewhere up here, if I remember correctly. The scale of protons, the one of the very, very tiny constituents of an atom, is in this range, if I'm remembering correctly. And then these ones are 1,000 times smaller than that, and 1,000,000 times smaller than that. So getting down to some very, very small units of measurement. Now, one thing I'd like to point out is I think it's just easier for people when we talk about the metric system in the example uh, of length and distances, but you can totally apply this to other things as well. So you could apply this to weights, in which case your base unit should be the gram, and then you'd have the decagram, the hectogram, which nobody really uses, and then we'd have the kilogram, which people use. And then again, nobody uses anything up there, but you could have an exagram, which is just 10 to the 18 grams. So it's like a kilogram. That is basically what that is. It's like it's a billion grams would be an exagram. But you could use that. You could use that to describe weights. And similarly for volumes, if you were talking about volumes, your base unit would be the liter, in which case you could have a kiloliter, or you could have a milliliter, right? We've seen probably at some point in our lives milliliters, milligrams, things like that. We can use these same prefixes to talk about other things. It doesn't all have to be lengths and distances. We can use it for time. Now, time is a bit weird because going from seconds to minutes to hours to days feels very Imperial System-y in that there doesn't seem to be a very simple logic to it. But once you try to get smaller than a second, you do have milliseconds and microseconds and nanoseconds and picoseconds. So going down smaller than a second, we do use these words here in the metric system. Going larger than a second, we don't use these because a minute is 60 times the length, the duration of a second, and an hour is 60 times that, and then a day is 24 of that, and it's just the numbers don't work out well enough for any of these terms to catch on. We don't talk about things in terms of kiloseconds. We just use minutes instead. Um, but yeah, so that's sort of an introduction to all the prefixes in the metric system. There could be more that go above this. I think these are the ones that are sort of defined within an international standard of some kind, with a top boundary here and a bottom boundary over there. On the next slide, I don't have anything new to add. It's just in this slide, I broke apart one long table into the higher end and the lower end. On the next slide, I'll just show you sort of the whole table put back together. So here you can see the table sort of in all its glory. We've got the iota meter, or the iota whatever the base unit is, way up at the top, which is like, let's see, that's like a million of the base unit. And then we've got the exact opposite down at the other end with a yocto, whatever, yoctometer or a yoctogram or a yoctoliter or a yoctosecond. And so this is just the whole table top to bottom. You can see where the base unit would fit in quite nicely right here. So if we're talking about meters, then I could put an M right here for meters. And then you could build larger and smaller units just by adding these prefixes to the meter. And if you wanted to write it down as just the short form, like the M for meter, then these are the symbols that you would attach in front of them. So for example, an hexameter would look like this, 1 hexameter, whereas 1 zeptometer would look like this. So you just add the symbol that it's got in this second column, you just add that symbol in front of the symbol for your base unit, and you've written down whatever that unit is. So here we've got hexameters right there, and here we've got zeptometers down there. Notice that we tend to use a lot of capital letters on the big end, so if I wanted a zetameter, then that would be 1 zm. So notice the difference, that here we've got a lowercase z and here we've got an uppercase z. But yeah, they're the prefixes in the metric system, and that's kind of all you need to know about them. So just as a quick example here, this is for lengths and distances. I've just written down a few of the actual words so you can see them. And I've got 3 slides that look like this. They're not they're not explaining anything revolutionary because you've already seen it with all the prefixes, but now you can see some actual words being written in with these prefixes. So for a base unit of the meter, we can go larger and smaller using the prefixes. So if we want 10 meters, then that's a decameter. If we want 100 meters, that's a hectometer. If we want 1,000 meters, that's a kilometer. So we just add in these prefixes of deca, hecto, and kilo to go up by a factor of 10 here, and go up by a factor of 10 here. So we're going up, so we're multiplying by 10, multiplying by 10, multiplying by 10 in this direction. And if we want to go in the other direction, if we want 1/10 of a meter, then that's a decimeter. And if we want 100th of a meter, that's a centimeter, which is 1/10 of a decimeter. And if we want 1,000th of a meter, then that's a millimeter. So going in this direction, we're getting smaller by a factor of 10. So this is dividing by 10, and then this is dividing by 10, and then this is dividing by 10. And there you go. So that's sort of how this works with lengths and distances. We just add the prefix in front of meter, and it changes the size of the unit to be 10 times bigger, or 100 times bigger, or 1,000 times smaller, or 1,000,000,000 times bigger, or whatever, depending on which prefix we choose to use. Here's sort of the same thing, but for weights. So for weights, if we treat the base unit as the gram, then we can get some other units out of it by adding the same prefixes, like the decagram, which would be, whoops, I've left meters here, so that's a typo on my part. It shouldn't say meters here, and I think I imagine it's the same error on the last slide as well. But this shouldn't say meters. This should just say grams here. 1/10 of a gram. Let me write that in once as an example. 1/10 of a gram would be a decigram. And then same thing for the rest of the units. It should never say meter here. It should always say gram for all of these. So 10 grams would be a decagram, 100 grams would be a hectogram, and 1,000 grams would be a kilogram, which is hopefully somewhat familiar, and maybe milligram is also somewhat familiar to you. And then here we've got the same thing, but for volumes. And once again, I apologize. I've made the mistake of leaving meters here. This should say liters instead for all of these, because our base unit for volume is the liter. So this should say liters, and this should say liters, and this should say liters, liters, and liters, which we use L for the liter as our symbol for the liter. So same idea though, if we start with a base unit of the liter, then going up as we get 10 times bigger, that's a decaliter, then a hectoliter, then a kiloliter. And same thing going in the opposite direction, we've got a deciliter, a centiliter, and a milliliter. And that's it, that's the way it works. You could do the same thing as an exercise for yourself if you're interested, to figure out the different ways to write down a billionth of a second or something like that. But yeah, that's basically all there is to the metric system. So here you have it, just as a little diagram, that you start with your base unit in the center here, and then going in one direction or the other as far as kilo and milli are concerned, you're jumping in tens everywhere, at every step, and beyond that you're jumping by thousands to the other units that we saw, like mega and giga and so on that end, and micro and nano and so on that end. But yeah, going from the base unit to deca, that's multiplying by 10. Going from deca to hecto is multiplying by 10. And hecto to kilo is multiplying by 10. And going in the other direction, you're dividing by 10, dividing by 10, and dividing by 10. So there you go. That's how this works. That's how the prefixes in the metric system work, and that's basically all there is to this lesson. So if you have any questions, please get in touch with me in some way. Otherwise, I will see you all in the next video. Have a good one.